Okay, so let's get into data cleaning. Because trust me, you have a lot of reasons to clean your data. Okay, so let's start with handling missing data. So missing data is like the empty spaces within your data, so it would be replaced with an NA or a null, right? Meaning the same thing. There's no element in here. There's no input within this particular cell. It's empty. Okay, there's nothing here, right? That's what we are trying to deal with, handling missing data. Okay, as usual, we're still referencing the DataFrame DF like from before. Okay, and now we are going to be looking at the different ways we can handle data and missing data. Okay, so for every data you're working with, okay, every data frame you're working with, you would want to know the number of null values you have. Okay, so you want to know the number of null values you have. With that, you use df. In this case, that's our DataFrame .isnull. Okay, this helps you have a fair idea of the null values within your data frame in total. Okay, it helps you know the total null values you have in your data frame. In this case, we don't have. Okay, let me just use .sum. Should work, right? So here, let me explain the first case first. Okay, with this situation, it's like saying within DF, I want you to tell me which part of the data frame has null values and which part has no null values. Okay, so wherever you see false, to say false, no, we have values here. Okay, and wherever you see true, is saying yeah, no, here we actually do not have any value here. It's actually null. So yes, this is a null value. Okay, so it's just like a Boolean situation. It's equating to a true or false, right? But I want to know the sum of it all. Okay, so I'm going to be using the .sum method to just add it up. Okay, so just count each individual element that is null and just tell me, instead of giving me the data frame with true or false, right? Because it could be a very huge data frame and there's no way you can go through it, right? Just sum it up and see the total, okay, per column, right? In this situation, you don't even have to do this. If we are using your .info, okay, using .info, it just gives you everything. It tells you per each column, okay, which column has which number of elements, total number of empty values, But in any case, if you do have to do them quick summation of your null values, this is what you do. Okay, it gives you the null values by columns. Okay, then in situations where you'd want to actually just get rid of your null values, you use df. In this case, this is our data frame .drop NA, just saying drop all the null values, drop the NAs within our data frame. Okay, then of course you open brackets, right? I would advise that the data you have, you research into data you're working with. Okay, because every data you're working with is specific to an industry, specific to an area, so you wouldn't want to be deleting important information. Okay, usually I delete information and data that is like with the total null value being like 5% of the data, or like 2% of the data, or 3%. Like you get a very small amount of data, right? But then you want data that is repetitive for that. Okay, you want a continuous data situation. Okay, let's say if it's numbers, okay, you have a continuous numbering, so like the number could be 50, it could be 70, it could be 90, it could be 32, you get it? So with that, when you are just removing like 1% of the data out of it, 2% of the data out of it, it's expected, not in all cases, but it's expected to not drastically impact your data, right? But then if you are working with data where most of the elements in there are specific to that row, are specific to a certain in a case feature, you don't want to just carelessly be deleting it, right? Okay, so you only want to be using .dropna when you are very sure that the data you are deleting is not going to greatly affect your data analysis. It's not going to skew your data to a particular element, or like, you get it? Okay, so here dropna is used to delete or remove data from your data frame. Okay, so that's what dropna does. Okay, next we are going to be looking at let me just run it, to be honest. Oh yeah, right, I forgot on 1 minute. Okay, let's run it. We are deleting nothing here because we had new null values, right? Let's move on to fillna, as you would think, right? .fillna literally fills up your null values. Okay, where there are no values, it fills it up with whatever value you put in here. Okay, in this case, we said we are telling Pandas that within our data frame, we want to fill all the missing values with a 0. Okay, you could fill it up. Mostly you fill it up with either the mean value or median. Okay, according to how your data looks like. If your data is skewed, you want to stick to a median. Is also imbalanced, you want to stick to your median. But if you have a normal distribution, you go for your mean, right? So yeah, and sometimes the industry specific information helps you pick up the data, the particular number you'd be using to fill up your data, or elements you'd be using to fill up your null values, right? So yeah, it's just used to fill null values with specified elements, right? So yeah, that's it for handling missing data. Okay, so renaming and replacing data. Okay, for instance, let's say you have your columns already done, you've got your data frame, but then you have maybe a spelling mistake, or you have your columns misnamed. You get it? So for instance, if this column was ages and this column was name, okay, you'd want to change it up and you want to switch it up. Okay, just rename each column, right? So we are going to be learning how to rename a column, or in a case where an age was inputted into your score column, you'd want to change that. You would replace it with the actual value. Okay, there are so many situations where you need to rename or replace a value within your data frame. Okay, so we are going to be learning how to first rename a column. Okay, so here we are still referencing our data frame df. We're going to be using the command rename. As I already said, I've always been saying Pandas, Python is very easy to use. Okay, most of the functions and methods and these different commands we'll be using are self-explanatory. Okay, rename lets you know that you're definitely going to be renaming something, right? So df.rename, then the columns you want to rename. In this case, columns is equal to score. We are trying to rename this score string to exam score. Okay, and then here we are just telling Python to put it in place, in the sense that if we should rerun the, what do you call it, df again, it should have score in place of exam score. Okay, in the sense that if after renaming this particular cell, I should go and reference df somewhere else, right, within this working environment. It should have score still replacing exam score, because if you don't put it in place after this cell has been run, if you should run it again in another cell, you have your original data frame, okay, unchanged. Okay, so let me give you an example of what I'm talking about. Non C. Okay, so okay, we have it here, right? But if I should go in here and run it, we still have score. It gets it. So after it has run, that's it. You've gotten your output. That's it. It's not in place. It's not replacing the already existing data frame. So when you put in place here, it just tells Python that put it in place of the already existing data frame. Okay, that's just what it is doing. Okay, so yeah, in place, and yeah, if we should call for df, we'll have it in place, and anywhere else we should call for df, we'll have the new data frame with exam score replacing score, right? So let's go to replace. Replace, as you think, replaces elements, right? So in this case, we are saying that wherever we see 85.5, we want to replace it with 86.0. Okay, so here it's expected to be 86.0, right? So let's run it in there. Okay, so I have to just get rid of df over here. Okay, and try it again. There, so wherever 85.5 is, should temporarily replace 86. Replace by 86. Okay. Okay, so type of data. Like I mentioned before, there could be a mistake where your data was mislabeled. Okay, where a data type, for instance, let's say it was a string, it was mislabeled as a float or as an integer. You know, it could happen. It happens all the time. So in a situation like that where you want to change it to another data type, you have to first reference that particular column. Okay, so in this case, within df, we want age, right? This is where you're going to be making the changes. Okay, so here you're saying that now this is the new data, this is the new column for age. Okay, it's like saying, I'm writing, I'm changing something. Okay, I want you to use it to replace df age. Okay, it's creating a new column called dfh and replacing the old age, right? So it's equal to, you make reference to your age column, df age, and then dots as type. Okay, this is where you change your data type. Okay, so using dots as type gives you the opportunity to change it from the existing data type to whatever data type you want. In this case, we want to change it to a float. Okay, we could have changed it to a string, to an object, right? Or an integer, or it could be anything really, but it should make sense for the data we're working with. Okay, it was flip, and just stick to it, even though it was flip, and just stick to it, and if I should run it, we have it in place. Okay, now our data type for age is float. Okay, when you are correcting anything within a column, you'd want to always replace the column. It's just easier. Okay, and to be honest, that's the only way you work with it easily. Okay,